Relational expressions in MATLAB. What are relational expressions? So all those mathematical expressions where you're comparing two things, they are called relational expressions. Like equal, not equal, less than, greater than, less or equal, greater or equal. All of these are called relational expression, and whenever you're comparing two variables or two quantities using relational expressions, the output will be either 0 or 1 based on, let's say if you're using equal, if A equals B, then if they are equal, the output will be 1. If they're not equal, output will be 0 of that expression. In MATLAB, when you're using equal relational expression, they are used using two equal sign. Remember, for one equal sign, that is used for assignment of values. A equals 4.5. So there's an assignment of values. But if you're comparing two variables, A equals B, then you have to use A, two equal signs, B, and that's going to be the comparison or the relational expression. Where do we use relational expression? Relational expression are very commonly used with if statement and with while statements, while loops. What are if statements? If statements are basically, if this is true, then do this, otherwise do something else, otherwise do something else, and if nothing is true, then by default do that. So you can have multiple types of if statements. You can have if only, you can have if else, if x equals y, let's say, then do this, else do that. Or you can also have multiple else's. That is, if x equals y, do this, else if x equals z, do this, else if x equal k, do this, and at the end you can do the default else. If none of the expression is true, then do this. So if statements can have if statement, if else statement, and if else if statement. All three of them are discussed in this tutorial. How to create if else loop structure, sorry, not loop, structure. It is very simple. If and the condition, if x is less than 10, let's say, then increase the value of x by 5. So add 5 into the value of x, and then y is equal to x square. Evaluate y, x square. So let's say if you enter input, so if you enter x 20, then this condition will not be valid. X will not be less than 10. So this if structure is not going to be executed, and it will be omitted, and the program is just going to jump to this line, and it's going to be 20 square, 400. That will be your answer. Now if you enter x equals 5, right, then this condition is going to be valid. This will be executed. X is equal to x plus 5. That means new x value is going to be 10. 5 plus 5. And then it's going to come out of the if statement, and then 10 will be used here to calculate y. 10 squared, which will be 100. So that's how you're going to use a simple if statement. Next thing is, you can also use two conditions to be compared in if statement. If x is greater or equal to 0 and x is less or equal to 10, that means x, this is defining the range. So x has to be between 0 and 10, including 0 and 10, and you're going to use and if both the conditions should be met. This is the Boolean AND, remember. And in MATLAB or in Octave, you will also see the recommendation of using two AND signs. So you can either use two AND signs or one AND sign. I think both work similarly. So you can use two conditions, or even you can use three conditions. If you have three conditions to be matched, you can use three conditions. So in this case, as long as x is between 0 and 10, then this condition will be matched. Now in the previous one, x is less than 10 means all the negative numbers up to 10, and not including 10, right? Here you're defining a range. X has to be between 0 and 10 only, so no negative number and no value above 10 for this structure. So if x is, let's say if user enter -2, then this structure, if loop is not going to run, and y is equal to -2 square is going to run. But if x is equal to 6, then of course this is going to run. 6 plus 5, 11, x will become 11, and y will be 11 square. Okay. So in if loops, if condition, we use AND if both the conditions have to be met, and we also use OR, and OR is defined by the straight line. We also use OR if one of the conditions should be met. OR is if one of the condition is met, that's going to be output of this is going to be 1, and as long as output of this statement, this condition is 1, whatever is written in the if loop is going to be executed. Okay. If else statements, again, as I mentioned, if this condition is true, do this, and if the condition is not true, then do this. That's if else. And make sure all the if statements and if else statement, they have to end with an AND command. Now in Octave, it will automatically end it will automatically add AND if, and if you're using for loop, it's gonna add AND for. If you're using function, it's gonna add AND function. You don't need to add those things. Actually, if you add those, it may not execute in MATLAB, it will only execute in Octave. So I will highly advise you, do not use any you do not append the AND statement with anything else. Just use AND for loop, for while loop, for if statements, for the functions. Just use AND. Okay. Next thing is if-elseif. As I discussed you, if you have multiple conditions, if this happen, do this, if this happen, do this, if this happen, do this, then you use if-elseif. So if x is greater or equal to 0 and x is less than 10, y should be this. Else if x is greater or equal to 10 and x is less than 20, then execute this equation. Else if x is greater or equal to 20 but x is less than or equal to 30, then y should be executed according to this equation. If none of these is true, then just assign a 0 to y. That's it, right? So this is multiple else if statements. Check out example 16, a straightforward example. Not only read it, but please program it, so you can get added benefit of doing extra programming, and you will understand it better. Of course, the output, sample output, is given for some input. So once you program it, enter the same input, see you're getting the same results as I am getting. Exercise 16, same exercise as you did in one of the homework set earlier. That is, you're going to ask users to enter a vector with register values. Now once again guys, many of you made mistake that you ask user to enter only 3 values of vector or only 4 values of vector. You cannot restrict user to enter a specific number of values for the vector. User can enter as many values as possible as he can. So go ahead and ask user to enter the values of resistance as a vector, and then you're going to calculate the equivalent resistance as you did in one of the exercises earlier for both parallel and series. Assume that they are connected in series, the same values. Assume if they are connected in parallel, same values. So what will be the value in series? Of course, you're going to add all of them together. And what will be the values of the resistor in parallel? You know, this is a formula, and the same formula you used in the exercise earlier. Now in this one, you have to use a if condition such that if any of the value that user is giving is negative, then you're not going to execute this. That is, you're not going to calculate the equivalent resistance. Instead, you're going to give a message that values of resistor cannot be negative. Please enter only positive values, and then you're going to terminate the program, right? So if all the values are positive, you're going to calculate the equivalent resistance, series and parallel. Else, that is, if you have a negative value, then you're going to give a statement that values cannot be negative. How are you going to check values are negative or not? I'm just giving you one hint. There is a function in MATLAB which is called find. Basically, it finds the index of any vector for a specific value or range of values. So if you want, you can use find, and you can see if any of the indices of the vector, input vector, carries a negative value. So you can say, let's say, find, let me show you real quick. So let's say a is equal to 23, -2, 5, right? So if I write down find a is less than 0, then it's going to tell me second. The second index is less than 0, right? So this is one way you can find out if, in case you have a negative value entered by the user, and you can just output the statement that values cannot be negative. Of course, you can create the logic for that. So this is the exercise 16, right? So these are some of the sample output where all the values are positive. Is going to calculate the series equivalent and parallel equivalent, and if in case one or more values are negative, then it's just going to give a statement resistors cannot be negative, and it's going to terminate the program. So that is exercise 16.